All right. Show of hands. If you can see my screen and hear me, would you mind just raising your hand, please? I'm just going to do a check. If you can't see the screen, but you can hear my voice, could you let me know?
I can hear you,
I
but I
can
don't see
see hear
anything.
you, but I can't see you.
All right, so you can't see the screen. Give me 1 second. I was afraid of that today. It's a really messed up day. Okay, I just reshared. Could you guys confirm if you can hear and see the screen?
Dr. Cooper, can you hear me?
I can hear you now, Miss McDonald.
Okay, I can't see anything, and it says from my end. It says I'm the only one in the meeting.
Okay. Yeah, not too sure how that's happening. Uh, I can try to reshare my screen one more time. I'm gonna reshare one more time. You're not the only person in. Well, I think you know that. It's probably most likely a internet issue, right? My 10 o'clock class, the internet was terrible. It's probably bad right now. I'll have the recording that you guys can go back and listen to. And then I'm gonna give you guys the PowerPoint slides for this as well today. All right, I'm gonna say good morning to you guys. And hopefully at this point you can hear and see. One more check. If you can see this screen and hear me, would you mind just raising your hand? Okay, I have a few people that say that they can. All right, it looks like a good amount now. It's probably about 6 hands. So I'm gonna assume that most of you guys should be able to see the screen. If you're having issues, would you guys just mind maybe re-logging back in or re-ensuring that you have a stronger connection, internet connection? All right, let's talk about this review. There's some practice questions that need to come your guys' way. I had some issues last night, so I'm gonna have to send those to you right after class today. So you can practice before you take your exam. I'm gonna change the deadline to midnight for the exam. Initially, I wanted to complete it by 5. It would make my life a little bit easier for your midterm grades, but I can have it by midnight tonight, it'll be fine. So I highly recommend to glance at the practice problems. If you don't want to try them, you don't have to, all right? But I will release a key for those practice problems as well. So you can try the practice problems and look at the key and then take your quiz, all right? Ideally for this quiz, I'm gonna ask one question each on one of the following topics that you see on this slide. First, nomenclature, that's misspelled, I'm sorry. The second is acyclic conformations. I might have something on cyclic conformations. I'm still thinking about that. A chair conformation question for sure. Identifying chiral carbons and assigning a configuration as either R and S. And I'm probably also going to ask you to assign those priorities of the groups when you make that configuration assignment, all right? I got a few problems here that we'll cover today to kind of make sure that we're comfortable with that. Monday, we're going to continue with chapter 5. I'm planning to be done with chapter 5 by Wednesday. So that means that next Friday, we'll have a review. I'll take any questions that you guys might have. But Friday after class or after the lecture, you would take exam 2. And again, exam 2 will be available electronically as well as you're having an opportunity to come in person. However, today's quiz, you do not need to come in person. Every student will take it on Canvas. That means that I will not have the lockdown browser nor the webcam options available. You will take it the normal way, okay? So please be prepared to complete your quiz by midnight tonight. I will change all those settings as soon as I get in my office, all right? I haven't been in my office yet. I came right to the classroom when I got to campus, all right? Is there any questions with anyone with the quiz that they need to complete today or any other topics? Any questions for anyone? Yes, no?
Nope, let's get the show on the road.
Okay, so no one has any questions. Good. Let's cover nomenclature, all right? I'm hoping that everyone is comfortable with nomenclatures at this point. You guys know that you want to start naming things with the substituents first. You want to move into the parent chain prefix. You want to have your ending, right? We talked about all these unique features that you guys want to be comfortable with when it comes to naming, right? Substituents, branching substituents, multiplicity, and halogens, all right? And also the word cyclo to describe anything in a ring. I'm not going to belabor the point here. Let's start with our first question here. Could we systematically name this following molecule? I'm going to put this on the side. And for the students that have been asking me and questioning, coming back for questions and coming through office hours, these are some of the things that I'll make sure you guys are thinking about. But I wanted to say this too. This class is very unique. You guys are the lowest scoring class that I have, but also you are the lowest amount of people that come by during office hours, right? You guys have the option that no other class had, is that you guys can contact me virtually. There was a whole activity sheet on nomenclature. I only had one, I'll take that back. I had 2 students, I'm sorry, that came by to try to see if they were naming those molecules correctly. So I'm going to assume that you guys can name. Let's see. Could we name this molecule here? All right, again, our rules for naming. I need to identify the parent chain. I need to properly number that chain. I need to deal accordingly with substituents, and then I need to name the molecule starting with substituents, giving the prefix of the parent chain, and then ending with the functional group ending, all right? So sub down there stands for substituents, prefix is the prefix for the parent chain, and FG stands for the functional group, okay? So I'll give you guys a second to think about this. And we'll break this down by the steps. I'll do steps 1, 2, and 3, and 4 to try to reinforce the learning for this section. So can anyone tell me what's the longest number of carbons in the chain?
9.
Okay, so somebody says 9. Let's take a show of hands.
You could count it 2 ways.
Okay, good. So you guys are definitely seeing that. That's very good. There's 2 potential ways to number this chain. I'm not going to have the option to really do a lot on, or maybe I can. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9 straight across, right? And I can say 1, 2, 3, 4, 5, 6, 7, 8, 9. If you can't do this at this point in class, you have failed behind. All right, that means that you're not taking the time to practice. There's no other way I can say that than saying this like this, okay? You want to make sure that you can identify the parent chains. There's 2 chains, going straight across or starting halfway and coming down. Which chain is the parent chain? Going straight across or the chain that's coming down?
No one is going down.
Okay, someone says the chain that's going down. Can I take a show of hands? If you believe the chain that's going down is the parent chain, can you raise your hand? Okay, there's maybe 4 hands. If you believe the chain that's going straight across is the parent chain, could you raise your hand? Okay, I think I got a few people also saying the chain is going straight across. All right, so we need to get on one accord. Could someone that voted first for the chain that's going down, can you tell the class why you voted for that chain?
Because it has 5 substituents where the one that's going across only has 4.
Okay, so someone says that I know the parent chain should have the most substituents, right? So if I go down, I can see a parent chain that has 5 substituents. If I go straight across, there's a parent chain that only has 4 substituents. Okay. What about those that voted for the chain going straight across? Why did you vote for that chain? Okay. Not too sure why you voted for that chain. All right, the correct answer is.
I ain't gonna lie. Hold on, Dr. Cooper.
Yes, sir.
Me. My fault. I ain't gonna lie. It's a lot of people in here that's not answering a lot of questions because they simply just don't be knowing what's going on. Honestly. Cause like I be sitting here and I be listening and like I be trying to learn and take my notes and stuff, but at the same time it's just like I be writing. Like I don't be knowing what I be writing, but I just be writing it down. Then I go back and study it, but it's like, why did I do this? You see what I'm saying? And then
Yeah.
I try to go back and look at the lectures, but we never really covered that topic.
Okay. My best bet, what to say, is to try to contact me during office hours.
But and that's all you say. But we gotta come on, office hours. We be trying to learn it in class. We got 50 minutes to hit it hard. We got other classes. We can't come to office hours you feel me? We can't come to office hours every other day. We got other classes. But I'm saying, like, I feel like in class we should discuss it because I don't get it sometimes by myself, honestly. And I know I'm not no real slow guy. I can catch on to stuff real fast. But like I honestly like don't get it. I be looking at YouTube videos and all, and it's just like I just still can't get it.
Okay. All right. All right. Well, thank you for voicing your opinion. Let's try to work this out. I'm not too sure. Can you tell me your question? So the first skill. So let me say this though. I definitely want to say this if this can help. The skill to really master these 4 points comes through working the problems. All right. And I sent you guys an activity sheet, right? Where you're supposed to like first try to practice finding the parent chain, try to practice numbering the chain, try to practice dealing with constituents, and then writing the names, right? That was a great opportunity to come by and say, Dr. Cooper, I tried your worksheet and maybe I can't find the parent chain correctly, or maybe I can't number the chain correctly, or I didn't come up with a name. So the fact that no one, maybe two students came by to even show me that they were trying to learn those skills, that's the only feedback that I got that there was problems, right? So for the most part, I assume that you guys were pretty comfortable with this.
Because I'm gonna go home today.
Now, kind of that
So you can just drive, and if we have to.
someone has their mic on, I'm gonna have to mute this more. So I think that was Mr. Augustus, right? You're gonna have to give me some more feedback. Let's work on the parent chain, right? So are you able to look here and see that the parent chain has to be 9 carbons each, right? If I go straight across here, that's a total of 9, right? Do I need to count them out? 1, 2, 3, 4, 5, 6, 7, 8.
All right, I know how to count the carbons, but can you explain to me what like I don't know. It's hard to explain because I understand we're not in person and you can't really just put your hands on it like you want to. But it's like you just be going through it. Like I know how to count the carbons. I understand it was a part in time where people ain't know how to count carbons stuff. But I understand how to count the carbons. But can you just explain to me? All right, so it's 9 carbons here and it's 4 carbons here. But can you explain to me which one is which one is why it is what it is?
Yeah, sure. Let's do that. I'm gonna put a 1 right here. Well, if it lets me. I'm gonna put a 1 right here. Can I reshare the screen? Okay. I'll reshare the screen one more time. Okay, I just reshared. Can you guys see now?
No, sir, I can't see it.
Okay, I'll reshare.
I see it now.
I'm gonna reshare one more time. I heard somebody said no, so I'm gonna do it one more time. And I'm glad that you guys are telling me. I feel bad now. Maybe this whole time you couldn't see my screen. I didn't know. All right, can you guys see the screen now?
Yes.
Okay, I'm hearing yeses. Any no's? Speak now, please. Okay, so let's work on this first chain. We said that there's a chain that goes 9 here, right? And there's another chain that goes 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm gonna put a 9 here. All right, I'll put the 5 right here. All right, so there's 2 potential ways that we can get 9, going straight across or coming down. So the parent chain here, I had the tie, is the chain with the most substituents, right? So if I look at the chain that going across, this would be 1 substituent, this would be 2 substituent, this would be 3 substituent, this is 4 substituent, and this big thing here is going to be the 5th substituent, okay? So you guys cool with that for this first chain that goes straight across only? All right, make sure you guys are keeping track of that. This first chain that's 9 that goes straight across is a total of 5 substituents. All right, I have to use this to break that tie. Any questions with that so far? Yes or no?
No, I'm good.
All right. I'm gonna go ahead and erase this if you guys don't mind. So now let's come back. I'll put a 5 here. I'll put a 9 here. Let's work on the chain that goes down. Let me see if I can erase this little line up top. Okay, this gives me 1 again, 2 again, 3 again. This whole thing as a substituent. So that's 4. Now I have this as a substituent here, because this is 5, 6. 7 has a substituent, and that's all. So this gives me a total of how many substituents for this chain that's going straight down?
Five.
Okay.
No, six.
6.
All right. The total is 6. All right. 1, 2, 3, 4, 5, and 6. Right. We said the last chain had 5. This one has 6. So that means the chain that has the most substituent is going to be the parent. So this is why 1 through 9, this direction is the parent chain. All right. Does that answer the first question that came up? Yes, no?
Yes.
Okay. All right. And again, I'm hoping that this skill was built through that worksheet that I gave you guys. All right.
And Dr. Cooper,
Yes, ma'am.
like the reason that you're counting backwards, right, is because like the 2 gets to the constituent first. Or that's the reason why you're counting that way.
Maybe.
So you couldn't count the other direction.
You could. And you have to check which counting is correct. Okay.
So what's your reasoning behind counting that way?
Okay. Let's work on that. All right. I'm sorry. I thought that's a skill we had too, but we'll work on that. All right. So as everybody's comfortable that we identified the right chain, right? This is the chain of 9. The next skill is that I have to provide the lowest numbering for substituents, all right? That's why that's going to be the only way to number things correctly. So let's work in the red really quickly. I got 2 substituents at 2, so I'm going to say 2, but let me draw. Oh boy. Sorry, the connectivity is bad today. I might not be able to, okay, 2 and 2, right? That's my first substituents. I got a substituent on carbon 4.
Dr. Cooper.
Yep, substituent 5.
I can
Go
only
ahead.
see your profile picture. I can't see your screen.
Okay, I'll try again. I thought we was trying to, I tried to establish that. I'll reshare my screen one more time. Okay, I'm sharing my screen. If you cannot see my screen right now, could you please let me know? Don't be shy. Just let me know.
I can't.
Okay, you can't see it.
I can't see it either.
I'll try one more time. All right, can you see my screen now?
I can.
I can't. Can I just leave and like re-enter?
Sure, sure.
Hey, Dr. Cooper, you got office hours today?
I will, I can. Right after class, hit me up.
All right, I'm gonna come over there as soon as it's over with.
Okay, come see me. You need to see me before this quiz. Come see me ASAP.
All
It's
right.
not it's not due to midnight. I'm on campus until 5 o'clock. I'll be available till 5 today with you guys. All right, just come see me. Okay, let's keep working on this. I got substituents on carbons 2 and 2. Carbon 4, carbon 5 has a substituent. Carbon 6 has a substituent. Carbon 7 has a substituent. Sorry about that. And that's it, right? So if I add these together, I'll get a number, and I need to compare it versus the other numbering, right? So I'm just looking for 10. I see 6 and 4, that gives me 10. And then I have a 4 and 9 and a 7. All right, so I'm gonna take the 5 and the 7 to give me to 12. So 10 and 12 is 22. And then I got a 4 at the end. What does that give me? Can you guys hear me? Did I lose you guys? Oh man, I lost the class. Okay, give me one.
Say it again, Dr. Cooper.
Oh, you guys can hear me. I thought I lost you guys. I'm just trying to add these numbers together. I'm taking 6 and 4 first, which is 10 plus 12. That gives me 22, right? And then plus another 2 is 24, and another 2 is 26, right? Is everybody comfortable with that so far? If I add all these substituents up, I get a number of 26. All right?
That's how many carbons are in each.
No. Yeah. I'm choosing the numbers where substituents are located just to make sure that the numbering is low. So if I add everything up, I get a number, and I'm going to compare it to the other number I get. All right. So I could start my numbering this way, which is, give me a sec here. Sorry, I meant to change the color on that. I could say
the number is the number of carbons in each constituent, right?
not the number of carbons in the substituent, just where the location, just the location of the substituent. Does that help?
I'm gonna need an example.
Okay, I'm gonna just do this one. Let's do the blue, if you guys don't mind. Just determine the location of a substituent by blue. So blue has a substituent at 3. You comfortable with that? A substituent at location 4. A substituent at location 5. A substituent at location 6, and 2 at 8.
All right, I see how you number it.
Okay, so maybe I should put these boxes around. That would have helped too. I'm sorry. Okay, are we comfortable with that so far? So I got 6 and 4 again, that's 10, and then I got 16. So 10 and 16 is 26, and what's left behind is an 8, right? So 26 and 8 gives me what, 34? You guys are younger than me, you can do math better than me, so let me know if I'm wrong. All right, are we cool?
Oh yeah, you correct. It's 34.
All right, what number is lower, 26 or 34?
26.
So that means which is the correct way to number the chain?
The one with the one right, the red way.
The red way. All right. So are you guys comfortable with why I number this way?
Yeah.
Anybody else? Please speak up. I didn't know. I'm sorry. I've been moving maybe fast. I thought it was cool, Gucci cool. It's all right. It's all right.
I understand it now, Dr. Cooper. It's just like when I asked, I had watched like some YouTube videos on it, and they showed me like a different way. That's why I was asking, just to make sure I had it down.
Okay. Good. Yeah, there's a lot of different ways that we go about these, I guess. This is the way that I do it. I hope that helps. There could be some better strategies out there, but this is the way I like to do it. I just check. I always check. I just double check. Some people say, oh, start your numbering near substituents. That's not always true. That could be tricky, right? I could have put another methyl group down here. That would have made things tricky, right? So just check your numbering by adding up the locations. And the location total that's lower will give you the correct numbering for your chain. All right, so we did step 1, and I got the right numbering now, right? I need to deal with my substituents. Where they're located, those are my substituents again. Can you guys help me with the names? What's the substituents on carbon 2? What do we call those?
Dimethyl.
Dimethyl.
Methyls. And 6 is called what? I already gave it to you already.
Isopropyl.
That's isopropyl.
Isopropyl.
Okay, carbon 5. All right, location 5. What is that suspension?
Is that a
It's
sec?
gonna be complex, ain't it?
Okay.
Isobutyl.
It's gonna be
Is it a sec butyl?
it's gonna be complex, right? We're gonna have to name it as a complex constituent.
Okay. Okay. I got some things coming in. All right, let's count how many carbons in this thing. 1, 2, 3, 4, and 5, right? So it's 5 total carbons. And the family of branching that I had you guys know are only 3 and 4. So this is a carbon chain
Complex.
that's branched. So we're gonna have to call this a complex sustentient. All right, is everybody comfortable with that? All right.
Yes.
So only the 3 carbon branching and the 4 carbon branching is appropriate for this class. You can use those names. Anything bigger, you would have to use the complex sustentient naming, right? Ideally, this is known as an isopentyl group. So if you recognize that, you're doing a really good job. This is known as isopentyl. But we can't use isopentyl for this course. So we need to use a complex sustentient. Let me break this down because I didn't break it down when I put the answer up. How do we number, or how do we start to name complex sustentients?
The number 1 gets the one goes to the carbon connected to the parent chain.
That's right.
So it'll be the first carbon next to the 5.
Very good. 1 automatically has to be the first carbon attached to the parent chain. All right. This is attached to the parent chain at location 5, right? This is the first carbon. That has to be 1. So automatically, this is what? 2, 3, and 4. And you just named this as a separate sustentient with its own little parent chain and all that kind of stuff, right? So that means I got 4 carbon chain with the sustentient at carbon 3. So this would be called a what group?
3-methyl-butyl.
Yeah. Bingo. Very, very good. It's isopentyl group, but with the complex naming, it has to be 3-methyl-butyl. All right. Is everybody comfortable with that? Any questions? I'm going to pause for a question.
All right, no questions, but I see. All right, so you say the first carbon starts at the one close to the parent group.
Yep, the direct,
All
the
right,
carbon
so
attached to the parent is 1. Go ahead.
which one? I don't know how to say it, but the one by 6, it was I what?
Oh, isopropyl. That's the isopropyl.
Isopropyl. All right, so would it be it'd be a 1 right there where the 3 bonds meet, and then
No.
a 2 at the end?
No, this is not complex. You have to memorize this branch name.
Okay.
So 3 carbons that branch like this is automatically known as an isopropyl.
All right.
Okay, good question though. All right, so we dealt with sustentants. We got all the names and branching done right. Do we have any multiplicity here?
Yes.
Okay, we do got multiples.
On the die. On number 2.
So what's the multiplicity that we should use for this
Tetra.
molecule?
Try. No, tetra.
Okay, good. There's a multiples of 4 here. Hope everyone can see that. There's 4 methyl groups here, right? So we have to use the word tetra to describe those. So if I want to start a name alphabetically, what comes first?
Okay, that's what my question comes in. Is it the complex one first, or does it just fall in with everything else?
You would use alphabetical for that too.
Okay.
It would be
So 3-methyl.
methyl first. You put your methyl groups first.
All right, don't forget alphabetical, who's first? This I, right, on isopropyl?
Oh, yeah. No, okay. It's
I
the dash threw me out.
I coming from M, right? So hopefully you got.
It's just you had a dash.
Oh yeah. I probably shouldn't. I put the dash. That's the only way to really say isopropyl. I'm sorry. That dash is probably not appropriate. It's just a convenience. All right. So the name here should be first 6-isopropyl, because alphabetically the I is the letter that we use for isopropyl. 2, 2, 4, 6. There's an extra number here. What did I do wrong?
Okay.
There's. Oh, give me one sec. There's a typo. There's a typo here. Can I fix it? There was more numbers that should have been down there. I'm sorry.
One.
That 6 is not right. All right, there we go. 2, 2, 4, and 7 tetramethyl. Okay. Then my complex extension is on carbon 5. I put in parentheses 3 methyl butyl. I have a total of 9 carbons, so there's 9. It's all single bonds, so the functional group is the alkane, and it'll be ane. All right. There's a question that popped up. Go ahead, please, with the question.
I thought when it came to like as far as like maybe the branches or the naming the alkyl groups, especially like the propyls, when you do the isopropyl and the isobutyls, I thought it went by the P or the B, not the I.
Nope. That's only for the sec butyl and tert butyl. So let me see. I thought I had this slide here. Here we go. So if you guys want to, please commit this to memory. Iso is always I, if it's isopropyl or isobutyl. But if it's anything else, it's gonna be the propyl or the butyl. So sec butyl is B, tert butyl is B, N butyl is B, N propyl is P, but every iso is the I. All right, that's the way to memorize it. Iso is one word, isopropyl, isobutyl.
Okay, thank you.
Mm-hmm. Any questions here?
How do you know where to put the complex one, like when naming it?
Yeah, alphabetically. Yeah, that's a good question. That's a very good question. So because this is methyl butyl and these are regular methyls, I put the methyl before methyl butyl. All right, does that help a little bit there? Tetra isn't used for any alphabetical stuff. So it's M versus M, but because this is methyl and this was methyl butyl, this is alphabetically will come before this additional letters here in the word butyl. All right, does that help?
Yes, sir.
Okay. Any other questions? Please speak up. I'm so sorry. I didn't want to be moving fast. I didn't want anyone to feel like they didn't get this down. Okay. I'm going to jump to chiral carbons because this is a skill that we haven't done. So I want to move and do something else. All right. Can you guys tell me in this structure how many chiral carbons are present? Let me make this a little bit bigger. Can you guys see it or should I make it bigger? I'll make it bigger. And then we're gonna do one configuration before we leave today. And I guess I need to go back to a chair if I can. All right, can you guys tell me in this molecule how many chiral carbons are present? I'll use the pointer just because I'm moving out of order right now.
6.
3.
Okay. Somebody says 6, somebody says 3. Before we start to move forward, can somebody tell me, how do I find a chiral carbon?
It has to have 4 bonds.
Have 4 groups.
Okay. It needs to have 4 groups, or can you guys give me a little bit more definition or more? I need a little bit more information.
It has to have 4 different groups.
4 different groups. That's very important there. It needs to have 4 unique groups. All right. So any carbon that has 4 unique groups can potentially be chiral. Let's just kind of work at some simple ones first, and then we'll start to get more direct here shortly. This carbon right here, can everybody see my laser pointer? Yeah, that didn't work out well. This carbon at the end, is that a chiral carbon?
No.
Can you tell me why?
Because it has 3 H bonds.
Okay, so somebody says this carbon has 3 H's on it, and H's are all the same, and I know I need to have 4 different groups. So if I have anything that's the same, it can't work out, right? So 3 similar atoms will make this carbon not be chiral. All right, What about this carbon here? Can everyone see where I'm at right here in the middle?
No.
I can't see your corner.
No.
Okay. Can everybody see now?
Yes.
Yes.
All right.
Yes.
That carbon there, is it chiral?
No.
Okay, good. Can you tell me why it's not chiral?
It has 3 CH3 groups.
Yeah, that's right. This carbon has 3 methyl groups, so that cannot be chiral. Is this carbon chiral? Can you guys see what I'm pointing at?
No. Well, yes, yes.
All right, can you guys see this carbon?
No.
Is it
I
chiral?
can't see it.
No.
I'm circling the carbon with the laser pointer.
She say no.
So you guys cannot see the carbon? That's what you're
We're
asking?
saying that the carbon is
No,
not
we saying
chiral.
it's not chiral.
Okay, all right. Can you tell me why it's not chiral?
It has 2 hydrogen bonds.
All right, what about this carbon right here? Is it chiral or not?
Yes.
All right, that carbon is chiral. All right. I don't know if that's even going to show up.
It showed up.
Typically, we write stars next to chiral carbons. All right, so this carbon right here is chiral. What about this next carbon here?
Why is that on chiral?
All right.
Yes.
Okay, this carbon is also chiral. This carbon is chiral because it has a methyl group, this long chain right here. All right, this is it's a neopentyl group. Well, it looks like a tert-butyl group. It's neopentyl. It has this isopropyl group down here, and there's an H that's understood to be here on that carbon. So that this carbon here has 4 unique groups. All right, I'm not too sure. I can try to circle the groups really quickly.
Oh, so the groups are just something you just have to recognize.
Yes, you have to look at this carbon and see what's attached to it, right? It's a methyl group up here. Then there's this thing here, which is neopentyl. Then this same carbon has all this stuff. And then there's an H that's not drawn. All right, so that carbon is chiral because it has 4 different groups. Okay, is everyone comfortable with that one? Okay, then that next carbon over is also chiral. Let's talk about that one, right? This one has that isopentyl group, this large complex constituent here, this large complex constituent here, and then there's an H also understood to be there. All those groups are different, so this carbon is also chiral. Okay, good. All right, let's move down. What about this carbon or that carbon? Are they chiral?
The one right next to it isn't.
Okay. This carbon right here is not. What about this one?
No, it's not either.
It's not. Good. What about this one?
It is.
One more time.
Well, it's not. It's not because it has 2 methyl groups.
This carbon is not chiral. And then this carbon here?
Nope.
No. And that carbon there is also no, right? So we have no chiral carbons over here. Any questions from anyone about
Can you
that?
go back to that middle one?
Which one? This one right here?
Yes, and can you explain how it's not?
Yep. This is a CH3 group. This is a CH3 group. Exactly the same. So I have to have 4 unique groups. CH3 are the same groups, right? Over here, this carbon had 3 of them, right? Over here, it has 2 of them. No groups can be the same off that carbon to be chiral. Does that help?
Yes.
Okay, let's move down here. Is this carbon chiral?
Well, Cooper, you said that it has to have 4 unique groups,
Yes.
but the one in the middle, you only put 3. Like you only circled 3.
Yeah, there was an H that I didn't circle, right?
Oh,
Which
okay.
was the fourth thing.
Cooper.
Yep. Yes, ma'am.
Jazz McDonald is trying to get in. She can't get in.
Okay, I didn't see her. All right, I just called her. Okay, let's go down to this carbon. Are we cool? You guys are cool, right? I didn't circle the H. I'm sorry, I didn't think I needed to. But there was 3 things that I circled and the H was different. So that made it 4 here and the same thing here. 3 groups that I circled and 1 H. Down here, is this carbon chiral?
Yes.
Yes, it is, right? Okay. Can you guys help me out? Let's look at the 4 unique groups for this one. Isopropyl is a unique group. Secbutyl
Secular.
is a unique group. This large complex constituent, and then there's an H that I'm not going to circle. That's also a different group. So there's 4 unique groups here. So that carbon is chiral. All right, let's keep moving down the chain. Is this carbon chiral?
Nope.
No.
Okay. What about over here at the end? I'm sorry, these carbons at the end, are they chiral?
Nope.
Yes.
No.
No.
Well, no, not that. I thought you were the other side. That was not chiral.
Okay. This carbon's not chiral, this carbon not chiral. So that's good. So we recognize that all of these carbons are not chiral. What about this carbon? Is it chiral?
That
Yeah.
one is.
Yes.
Yeah, very good, very good, very good. What are my 4 unique groups here?
You have an alpha group.
A methyl group.
I'm gonna
Hydrogen.
good.
We need like that.
Methyl, all this big jazz, right? This very large complex constituent, and then there's a what hanging off.
Hydrogen.
Yeah. So that carbon is chiral. Very, very good. Very good. All right, we're getting somewhere now. What about this carbon? Is it chiral?
Nope.
What about this carbon
Nope.
and that carbon?
Nope.
Nope, good. So there's how many chiral carbons in this molecule?
4.
Only 4. All right. You guys are getting comfortable with this?
Yes, sir.
Okay, good. Let's assign a configuration. Oh man, I'm out of time already. Okay.
So
Give
the
me,
one that was starred, is that the stereo center?
say that one more time.
The one that was starred on the chiral carbons we just did.
All the ones with the, I didn't start,
Okay.
but all of those are stereo centers.
Okay.
Yeah. Good. The word chiral is synonymous with asymmetric carbon. It's also synonymous with stereocenter. All right. Any carbon that's chiral will have to have 4 different groups, which is the same thing as saying an asymmetric carbon. And any carbon that has 4 different groups will be a stereocenter. That means if I exchange the locations of those groups in 3-dimensional space, I will generate a new stereoisomer. Okay, good. It's just convenient that we use all those words for a carbon. Okay, give me a sec. I'm moving around a little bit here. All right, let's do this. A, B, and C, which carbons is chiral here? Can you guys see the screen?
Yes.
What was the question again?
Which carbon is chiral?
There's it's the one that it's pointing to.
All right.
On A it is.
Is A chiral? The carbon I'm pointing to, is that carbon chiral?
Yes.
All right. Show of hands. Oh, wow. It looks like a lot of people got this one. This is the most hands I've ever seen in this class. Still not the whole class. All right. But it's close to about half the class. All right. Can you tell me why it's chiral then?
It has a bromine, a hydrogen, a propyl, and an ethyl.
All right, good. So carbon A, the one I'm pointing to here is chiral. What about on B?
No.
All right, I got some people that said no. If you say no, would you raise your hand? All right. Would you mind telling me why?
It
It
only
has
has
two hydrogen groups.
Yeah, good. That carbon has two hydrogens. Anything that's the same means that it cannot be chiral. All right, what about this carbon here? Is that a chiral carbon?
No,
Yes.
All right,
no.
somebody said no. Let's vote. If you say no, would you raise your hand? All right, there's a good amount of people that says no. All right, if you say yes, could you raise your hand for me? If you do believe it's chiral, could you raise your hand? All right, I got maybe
You gotta
three.
have a good reason, Kalisha.
I got about three people that said, yeah, it's chiral. Okay, for those that said no, can you give your explanation? Why do you believe that carbon is not chiral?
Because it's connected to what is it, a H3C and a what is that, a ET? I don't know what that is. Then it got another hydrogen at the top, but that it got two hydrogen groups.
This carbon right here got two hydrogen groups on it?
Yeah, that because that line is connected to that H, isn't it?
All right, so this carbon here has an H attached to it, an alpha group, ET stands for alpha, and a CH3 group. And then it has the big circle attached to it as well. That's the fourth atom attached to it, right?
So it wouldn't be a hydrogen directly connected to what a carbon is.
Only here, this carbon only has an H here, right? These two hydrogens are on the circle, which is the back carbon.
So it's two carbons connected and then three separate groups.
It's three carbons.
Wait,
Not too sure what
wait.
it's saying. So
No,
this,
I'm saying like the front carbon and the back carbon are bonded, and then there's three groups on the front carbon,
yeah,
right?
that's correct.
Oh, because do you see where my head at? Because I was thinking like it would be a hydrogen directly connected to the carbon, like how on the like how on A, how it's a hydrogen directly connected to the carbon.
Okay, there is a hydrogen directly attached to that carbon right here.
All right. No. All right, my fault. I said that wrong. Wrong example. On B, you know how there's imaginary hydrogens. You know how the hydrogens are understood. That's
Yep.
what I was thinking was going to be connected to the carbon in the middle of C.
Oh, okay. You thought there was an understood H that wasn't being drawn there.
Yeah.
Okay, I understand. In Newman projection, that's not how it works. You have to see every possible thing attached.
All right.
Okay, good. I can actually draw on this molecule. Um, so let's do this. Carbon 1 here, or the carbon in the front, has a methyl, an alpha, an H, and the big circle carbon, right? And we got to figure out what that group is. And then on the back carbon, we don't have to worry about the back carbon right now. So what is the group that's in the back? What is that called?
That's the back carbon. What you mean?
It's a group. It's an alkyl group. What's the name of the alkyl group in the back?
In the back?
Yes, ma'am.
It's a methyl.
It's not a methyl. It's an alpha group. Can you guys see that? The back carbon has a CH2 and methyl. That's a
Okay.
two-chain constituent. So that's alpha. So this front carbon has alpha group, another alpha group in the back, right? It's CH3 and an H. So is that carbon chiral?
No.
It's not, right? Because it has two alpha groups attached to it. Okay?
Can
So
you put out the other ethyl again?
say that one more time.
Can you point out the other ethyl again?
It's the big circle that has two H's on it and the CH3 group. Maybe I have to get this into the drawing program.
But wouldn't that be propyl because of the bond that they share? That would make the front carbon chiral.
It's not propyl. It's only two carbons. The big circle is one carbon, and that CH3 is the second carbon. Okay. Let me, let's draw as a straight chain first. Ah, my computer's stuck. All right, I think I might be done. I can't do anything else. I'm so sorry. You just can hear me, but my computer will not allow me to come out of this. Okay. All right, this is the molecule that you guys are seeing. This is 1, 2, that's 3, that's 4. But actually, I numbered this wrong. This is not the parent chain. I should have started on the alpha group. But just for convenience here, I should just use letters instead. I'm sorry. This is 1 here. This is 2 here. This is 3. This is 4. And I'm pointing right at carbon 2. All right, can everybody see that? So again, this is not the parent, this is not the right way to number this chain, right? I'm hoping everybody's comfortable with that. I'm just trying to give you guys some reference points. So if I use this first carbon as 1, this would be my 1 here. My carbon here is 2, right? 2 has an H that's understood. That has an H that's understood. Has carbon 1, which is a methyl, and it has this alpha group hanging off. I got this alpha group right here up top. All right. In the back is a big C that has 2 H's. So that's carbon 3 that has 2 H's and a methyl group hanging off. And that methyl group is labeled number 4. If I look at 2, it becomes very clear that there's 2 what groups attached to that carbon? 2 alpha groups, right? So this carbon cannot be chiral. Right? Did that answer you guys' question? Or did I lose you guys on Teams?
Wait, so you just said number 2 cannot be chiral?
Yeah, it's not. No way it's chiral. It's not chiral.
Okay, all right. So let me explain to you why I would think it's chiral. Okay, so I see the methyl group. Oh, would the one on top of that be considered a methyl group too, or you see what I'm pointing at? This substituent right here at the top.
Which one? Right, these 2 carbon chain right here?
Yeah, would that be considered a methyl?
No, 2 carbon has the prefix ET for alpha, right?
Okay. So that's 2 groups right there that I just named. Oh, then they got 2 ethyl groups. All right. I see why it is what it is.
All right, is everybody getting comfortable with that?
No.
You have a question? Go ahead.
I don't really have a question.
Like, I do have a question. I have a lot of questions, but I don't even know where to start.
Okay. Is there any way you can schedule some office hours, maybe?
Yes.
Okay. Good.
Today, like, can we do it virtually today?
Yeah. Yeah. You can see me virtually today. I'm supposed to be available right now. Actually for office hours. It's 12 o'clock. I didn't realize it's already 12. All right.
Mr.
We got time for one more question. Yes, ma'am. I'm sorry. Go ahead. Go ahead. I'm so sorry.
So, could we like in your office hours, could we finish reviewing?
Yeah. If you
Like,
need
could we finish going over the stuff?
yeah, sure. We can finish going over.
Can you explain how you went from that first figure to the second one?
Can I explain how I went from the first to the second one?
Like the Newman projection to the line angle structure?
Yeah, okay. I don't know. I don't know if I can explain it. All I did was I looked at this and redrew it. I just put mentally, I just identify each carbon. I had some type of way to identify the carbon and I did a straight change. So the numbers that I use here is mentally how I was keeping track of things, right? So I knew that there was a methyl group hanging off. So I started with a methyl group, right? And I realized that carbon 2 had an H and an ethyl. So that's what I did. I drew the ethyl and I knew the H could be understood here. And I knew that carbon 2 had a carbon that it was in the back, it was bonded to. So I went ahead and drew that carbon. And that carbon had 2 H's and a methyl group. So I knew the 2 H's were understood and I drew the methyl group. I hope that helps. But I think this is a skill that comes through this individual practice, right? Just saying that I want to see if I can redraw this correctly. And if you want me to look over, I got some time today, you can just ask me to look over something to see if it's done correctly. It's harder, I guess what I'm trying to say is harder to explain. There's no correct way of doing this. You just want to mentally keep track of what is drawn and try to redraw it back to make sure it fit. So I knew that this had to be a carbon with 3 H's attached to carbon 2. And I knew that carbon 2 had to have carbon 1, an H, and an alpha group. So I made sure that was present. Carbon 3 had to have 2 H's, this methyl group, and carbon 2, right? So carbon 3 has 2 H's, carbon 2, and then carbon with 3 H's, which we call carbon 4. And carbon 4 only had to be attached to 3. So I had it only attached to 3 with 3 hydrogens present. So I hope that explains. I just made sure that I drew something that matched what was bonded to up top. Okay. So with the last minute time that I have with students, let's just try to let's do a stereo center, and then we'll do a chair. All right. Can we assign the stereo center here? So let's start off with our 2 rules. Let's write these down. How do I assign a configuration? Somebody help me out. First, I set priorities, right? Number 1 is given to what? The highest priority, right? Which is the same thing as saying what? Atomic number. Be careful with atomic size because it gets tricky sometimes. Atomic size is like generally correct, but the rule says the atomic number is what we use. Okay. So that's step 1 is to set the priorities. Step 2 says, yeah, we're going to make sure we are absorbing the molecule with the smallest extension in the back. Then if the rotation to 1 to 3 is clockwise, it's going to be in sine way. All right. Or if 1 to 3 is counterclockwise, then we're going to assign away. Yes, right? Are we comfortable with that so far? Yes, no?
Yes.
Okay. Is there any questions for anyone? Please speak up. All right, let's go ahead and try to assign this Adams configuration. First of all, I have to be able to recognize that there has to be 4 unique groups here, right? Can you guys tell me the 4 unique groups?
We have a hydrogen,
Okay.
a secondary amide, and 2 primaries.
Okay. All right, I got the H as a group. I think everybody's Gucci cool here, right?
Yeah.
All right. And then I have this NH2, right? As a group. And then what else do we have? This methyl amino group down here, right?
But this wouldn't be chiral because it's 2 groups that are the same.
Okay. Which 2 groups are the same?
The amide group.
All right. Let's talk about that. All right. Is everybody comfortable? These are my 4 groups, right? So my first group has an H attached. This has a nitrogen attached. This has a carbon that has a single bond to a nitrogen. This has a carbon that has a double bond to nitrogen, right? So obviously all 4 of these groups are different, right? H, N, a carbon involved in a double bond to nitrogen and a carbon involved in a single bond to nitrogen, right? So those are 4 different groups. Are we comfortable with that? Which priority could we automatically set?
Hydrogen is the lowest.
Hydrogen has to be, oh boy, I can't see everything here. Hydrogen has to be the lowest group. All right. Wow, this covered up everything. What's it supposed to? All right, you know what? That's going to take up too much time. I'm not going to do that. I'm just going to color it. All right, so my carbon 4 has to be my smallest constituent. Who's next? Is there any other way? I got nitrogen, carbon, and carbon as my ties, right? Well, I got 2 ties and I got a different atom. So could we identify who's next? Who wins out of nitrogen and carbon?
Nitrogen.
Yeah, that's right, nitrogen. So that's going to be set what?
1.
Good. That's going to be my first priority. If there's any questions, please let me know right now. That'll
Can
be
you say that one more time? You was
okay.
kind
Nitrogen has a higher atomic number than carbon, right? Carbon, and then it's nitrogen, then it's oxygen, then it's fluorine, right? So the atomic numbers here are 6, 7, 8, and 9, right? Is everybody comfortable with that so far?
So when you're assigning priority, since the okay, so that's a carbon that second NH2 is attached to. So you're not looking at it's attached to another N. You're looking at it as it's a carbon attached to a hydrogen, a N, and two carbons.
Yes, I think I understand your question. You guys got to help me out. 'Cause I don't see what's confusing here, but it's just H, N, carbon, carbon, right? You have to look at what is attached to that chiral center. And I'm not too sure why, but I think I understand what's going on. This is not I get what you're trying to say. Students have a tendency to skip all the way to N, right? And that just doesn't make a lot of sense, but it's okay. If you do that, you just know now not to look at what's directly attached. That's what's going to give you your understanding of chiropractic. It's one group at a time, and we work backwards if we need to break those ties. Does that answer your question?
Yes, sir.
Okay, good, good. So I got a two-way tie. I got a carbon on this side. I'm going to put C here, and I got a carbon on that side. So how do I break these ties?
The next bond over.
That's right. Very good. So my initial carbons can't help. So down, I have a N down here, but I also have a what down here? An N, right?
N.
All right, so I'm still in a tie, right? What else is also attached to that carbon?
Hydrogen.
All right, so this one is, that's right, has an H. All right. What's attached to the other, on the other side, what's attached?
Carbon.
All right, so this one has a carbon. Did I break my tie?
Yes.
Yeah, right? You can also say that this carbon, and beware, has another what also attached to it? Another nitrogen, right? The double bond counts as what for that carbon? Having two nitrogens attached to it, right? So this carbon has two nitrogens attached and another carbon. This carbon has two hydrogens attached to it. So let's get the other hydrogen out there. And one bond to a nitrogen, right? So we win because of the carbon or the extra nitrogen that beats an H, right? So that means that this would be assigned carbon or priority 2. And on the other side, I'm going to be assigned what? Priority what? 3. Are we cool so far?
Can you explain again why that, like, why the priority for the the second priority?
Okay, you want me to go over why this is a 2 one more time? Is that correct?
Yes, sir.
Okay, so if I look at, okay, I'm going to put that carbon in red. That's the first attached atom. It's in red, right? So I need to break that tie. So I'll look and see what's going on. So this had a nitrogen. I'm going to call my blue, and this also had originally a nitrogen, right? I'll put that in blue. This carbon had a double bond to nitrogen. All right, so that's going to read as having 2 bonds to nitrogen. I'll put that in purple. But this carbon only had a nitrogen, and also attached to it is what? 2 H's, right? So I'm going to just put one of the H's in purple, and that breaks the tie. We are able to break the tie off of the purple color, right? So who wins out of H or nitrogen? You would say who? Nitrogen.
Nitrogen.
So that's why this is assigned priority 2, and this is just assigned priority 3. I hope that answered your question.
Yes, sir, it did. Thank you.
Okay, good. So if I look at my groups, I'm just going to move these to the side over here. All right, these are the locations for everything. I'm just going to make it a little bit tighter for me. First of all, am I looking at this in the correct configuration?
Yes. Yes.
All right, and what does that mean? Can you guys clarify that for me?
You have the smallest group in the back because the H is on a dash.
That's exactly right. Very, very good. Very good. So we are looking at this the correct way because our smallest constituent, man, what's going on with this computer? Come on, is in the back. So if I had to observe the rotation, this would be what type of rotation? Is that clockwise or counterclockwise?
Clockwise.
Counterclockwise. No, clockwise.
Okay, good. This is clockwise. And that means that my configuration here would have to be what?
R.
That's right, R configuration. Okay, any questions here? Actually, let me do this. I'm going to give you all this in a PowerPoint slide. Let me copy this. Edit. You guys can have this example. I don't need it. This computer right here, boy. Sorry, I'm sorry. Is doing everything outside of what I'm asking it to do. Okay, good. All right, let's do a chair question. And that'll be the last point I think we need to cover. Yeah. We did chiral carbons, we did configurations, we did nomenclature. Did we do any acyclic conformations?
No.
Okay, let's do one of those. Huh? Give me 1 sec. I got the slides.
Dr. Cooper, is the quiz posted yet?
No, it's not posted. I was supposed to do it right for class, but I'm still talking. As soon as I get out, as soon as I get done with this, I gotta tell it to make it public.
Yes, sir.
Just give me a few seconds. I'm so sorry. This is, boy, this is gonna be a pain in the butt right here. Sorry, this thing is really getting on my nerves right now. All right, I'm just gonna show you in the Word document. I'll just, because PowerPoint's not working. Okay, here we go. All right, could you guys tell me which is the correct Newman projection for 3,4,5,6 tetramethyl heptane? All right, this is a question, first of all, in making sure that you guys can use Newman projections correctly. I'll give you guys a few seconds.
I say G.
Okay, somebody said G. All right, so if you haven't figured out already, all right, and again, I told you that you guys need to look down the carbon 4 and 5 bond. I would just draw this molecule out first, right, in 2D. And then try to look at things attached. So give me 1 sec. I'm actually drawing this as we speak. 1, 2. Better place it. Bring it over here shortly. So somebody did say G, right?
Yes.
Okay. Keep working on it while I bring this up. Any other students? Nobody else tried it?
I think it's either G or H.
All right, so I said G or H. Give me 1 sec. It won't let me paste as a picture. All right, so hopefully you guys were able to draw this out. Let me get some space here. If you drew out the molecule, this is not working too well. Should have left it the way it was. Okay. 7 carbons, 1, 2, 3, 4, 5, 6, 7. On carbon 3, there should be a methyl. Carbon 4, there should be a methyl. Carbon 5, there should be a methyl. And carbon 6, there should be a methyl. All right. So I hope you guys are able to draw this chain out from the name. All right. Now, my emphasis is on carbons 4 and 5. And because carbon 4 is drawn or is written first, this is the carbon in the front. Carbon 5 is in the back, right? And if I look at the groups attached to carbon 4, there's a methyl group in this chain here, which is known as a sep-butyl group. And if I look at carbon 5, there should be a methyl group attached to carbon 5 and an isopropyl group. Don't forget that both carbons 4 and 5 also should have one H. So let's take a look at this. A here has an isopropyl group on the carbon that's in the front. Is that correct? No way. No way. So that's automatically wrong. Also, I have an isopropyl group here in the front. That's wrong. All right, over here, I have a sec-butyl group, a methyl group in the H for carbon 4. Is that correct?
Yes.
Yeah, that's right. What about the back? Isopropyl group, methyl in the H. Is that correct?
Yes.
C is incorrect structure. All right, let's double check to see if there's not any more. All right, what about D? Is D correct? Isopropyl on the front carbon? That's supposed to be carbon 4? That's not right. Isobutyl group that's on the front carbon. Is that right for E?
No.
No way. Isopropyl group that's on the front carbon for 4 for F. Is that right?
No.
No way. What about this sec-butyl group that's supposed to be on carbon 4? Is that right?
Yes.
Yeah, that's right. And on the back here, am I supposed to have isopropyl, methyl, and H?
Yes.
Yeah, so G is correct. What about H? Is that right?
No.
Isobutyl? No way. All right, so C and G are the correct 2 structures. If I had to ask you which conformer is more stable or the lowest energy between C and G, we both know that these are the same molecule, but they're different in their rotation. I'm hoping everybody can see that, right? There's an H methyl isopropyl on the bottom. However, this one has isopropyl on the bottom and the methyl and the H exchange. C or G, who's lower energy?
G.
Okay, anyone else? Anyone else? All right, good. G is a low energy. Can you tell me why?
Because you have your methyl spaced more apart in your S-butyl and isopropyl.
Okay. So set butyl isopropyl for both of these are 180 degrees. So that's okay. But right here between these two methyls, we have a strong interaction. Set butyl methyl and then methyl, the methyl isopropyl. What are the interactions called when they are 60 degrees from each other? What do we call that?
Gauche.
A gauche interaction. Very good. So this has a lot more gauche interactions than they do here. There's a gauche here, but there's not really a gauche here, right? Cert butyl to H, that's okay. H is as small as we can get. H to methyl is not bad, but isopropyl to methyl is bad. So there's two gauche interactions here. Isopropyl to methyl, methyl to set butyl is bad. Over here, there's four. Set butyl to methyl, methyl to methyl, and methyl to isopropyl, right? So these are all bad interactions. So this is higher energy than this one. So G is the lowest energy. Very, very good. Any questions there?
Can you go back up to how you drew it at the top?
Okay. All right, I'll wait a few seconds.
Okay, I got it.
Okay. All right, is there any questions? Let's do this. Can we rate these? I think we just almost did this. Can you guys tell me who this, can you guys see that this is higher, this is low, and this is kind of in the middle? Everybody's comfortable with that?
Yes.
All right. Who is the highest energy out of these three structures?
C.
C.
Okay, C, right? Because we talked about all these ghost interactions. Good. Who's the lowest energy between these two?
B.
Which one?
B.
Okay, somebody said B, and then somebody. So let's take a look at B, and let's look at the difference in A. A has sec butyl next to isopropyl, and then methyl methyl. And in here, I just have isopropyl next to methyl and sec butyl next to methyl, right? So which is better, you think?
B.
Yeah, definitely, right? What two things could you tell me is good about B?
They're 180 degrees apart.
Yeah, definitely. Isopropyl sec butyl 180 degrees, right? And I just have a methyl isopropyl sec butyl methyl interaction, which is not as bad as this thing right here, which is sec butyl right next to isopropyl, right? No way. Okay. So are we getting comfortable with that? So this is going to be in the middle. This is A right here. This is B and this is C. Is everybody comfortable with ranking these? Is there any questions that come up?
Can you say that one more time?
Oh, the letters?
Yes.
Okay. C, B, A. C will be the highest. B's in the middle, pretty low. And then A will be midway. And again, no problem. C is the highest because my two largest groups are gauche, but I'm gauche all the way through, right? B is the lowest because the isopropyl and the sec butyl group are 180s. So we call that an anti-staggered conformation. B is in the middle because I'm not all the way gauche. I have H's in between, but I still got a bad interaction here between sec butyl and isobutyl. So this is going to be higher in energy than this one, but not as high as that one. All right, good. All right, let's do a chair. There's a question here. It's on my computer. This is a quiz I gave you, practice quiz. Can I open this in? Yeah, I can open this in ChemDraw. So the question here is, can you guys give me the ring flip conformations for cis 1,3-dimethyl cyclohexane? Let's go into ChemDraw for this question. Actually. Okay. Let's draw the chair confirmation. Okay, let's start off with a chair really quickly. Updating 2 bars, what does that mean? Let's give it a chair. Oh boy, this is. I can't see the chairs. Let me do this side. Okay. All right, I got my chair. Let's do something really quickly. I'm not too sure. I realized that I didn't think there could be some missed points there. This is a cyclohexane ring. I think everybody knows that. What does cis means?
That both of the groups on
Bond
the
on the
same
same
side.
side.
On the same side. Very good. So I'm going to draw both of these wedges. You guys cool with that so far? We'll do the one for the where they're both dashed, right? I can do this, or I can say that they are both dash, right? So let's do this first. I wasn't too sure how good you guys are with this. So does everybody know how to draw the axial positions on the chair? So yes or no? All right, and axial, this stands
No,
for,
I don't.
okay, good. That's what I'm thinking. So we're gonna work on that. Let's work on that. All right, axial again means axis. All right, so this is the axis, and the positions that we're interested in right now are the axial positions. All right. So I'm going to use this strategy of a carbon pointing up and a carbon that's pointing down. All right. That's going to be very important for us. All right. So can you guys see that this is a carbon pointing up? Yes or no?
Yes.
All right. Okay. Let's put this in the box then. And that this right here is the look of a carbon that's pointing down, right? And I just changed my mind, so I'll give you guys a heads up. I'm gonna not give you guys a quiz today. I'm gonna give the quiz on Monday. You got the weekend to study. I don't feel like I'm realizing there's a lot of questions. So I'm gonna give you the weekend to study. You want to keep that same study guide, and Monday is gonna be available. All right. So hopefully that gives you enough time to get this down. But we're gonna work on this. We need to work on this. This is a carbon pointing. I got the arrow going the wrong way. I'm sorry. Okay. I'm supposed to be able to flip it, but it won't let me flip. A carbon is pointing down. Is everyone kind of comfortable with this strategy? I had to ask you what carbon is pointing up, what carbon is pointing down. You guys be comfortable with that? I'm going to put the letter here red because I'm going to use a red dot to describe that. I'm going to put blue here for all the carbons that are pointing down. So let's take a look. Let me get a circle here or a little dot. Can you guys help me identify the carbons that are pointing up?
It's the one on the bottom.
Okay. So this carbon right here, is it pointing up or pointing down? Can you guys help me out?
Pointing up.
Good. Let me get my other color here. So So this carbon is pointing up. Put a red dot here. This carbon right here, is it pointing up or down?
Down.
Okay. Next carbon right here, is it pointing up or down? Pointing up, right? This carbon right here pointing up or down?
Down.
Pointing down, that's right. The carbon over here, is that pointing up or down? Up, and this carbon right here is pointing what? Down, right?
Down.
Okay. So looking at a chair and being able to recognize if a carbon is pointing up and down is going to be very convenient for the way that I'm going to teach this. All right. So the axial position is always along this axial. So if I'm pointing up, axial is up. And if I'm pointing down, axial is going to be what you think? Down. So straight up, straight down. Up, straight down. Right? So those are all the axial positions. Maybe I should have not put H's there, but it's okay for now. So is everybody comfortable with drawing the axial position? Draw a line up for carbons pointing up. Draw line down for carbon pointing down. Right. That's how we draw the axial positions. Any questions there? Okay. So how do we draw the equatorial positions then? That's what we need to know as well. All right, and we know that the equatorial position is along the equator, right? So that's going to be in this direction. Or like you like to say horizontally. You guys still with me in teams, right? Or am I just talking to myself right now?
You still
Nah,
with
I'm
me?
listening.
Okay. All right. I wasn't sure. I did a whole lecture in one class and nobody was on the line, so I didn't realize. All right, good. So conveniently, we know what carbons are pointing up and carbons pointing down, and we're not going to draw a straight line up and down anymore. We're going to have to draw slanted lines. All right, and the slanted line for this carbon, let's go ahead and call this a red carbon, is the line that is not touching. All right. So this line, can you guys see that this line, maybe I'll make it bold. That line is touching and that line is touching that carbon, right? So we get the way it slants for the lines that are not touching it. Next one over. So these two lines here are equivalent. I'm going to color those red if I can. Give me a sec. That carbon or this line, I'm sorry. Not a carbon, but it's a line. All right. So that tells me that drawing equatorial for this carbon should be here. All right. You guys are comfortable with that so far?
I didn't get that. I don't understand that.
Okay. Can you tell me what you didn't understand?
When you said not touching, are you referring to like not touching that carbon at the
That's
end?
not touching the red carbon right here. That's correct. So this line that's bold is touching that carbon, and this line that's bold is touching that carbon, right? So I look over at the next line, which is this one right here, or this one. And both of these are slanted in this direction. So when I draw equatorial, I'm going to slant it the same way. So this
Oh,
is,
okay. So you gotta imitate that line.
that's correct. That's
Okay.
correct. All right. So that tells me how to draw equatorial off of that carbon. Let's go back to the blue carbon if I can grab it right quick. All right, so now this is my blue carbon down here, right? So again, I can't, well, this is tough. Let me redraw this chair. Okay, So I want to focus on the blue carbon down here, right? So again, any line that's touching I can't use, I'm sorry. So this and that are touching. Send that to the back. Send that to the back. Okay, so now I have to look for the lines that are next over. So it has to be this one. I'll color that blue. And I need to color that one blue, right? So this line is going to look like that, right? And again, you don't want to draw it in this way. You don't draw any equatorial positions inside the ring. Everything has to be outside the ring, right? So the slant looks like this, and you draw it outside of the ring like that. All right, so let me trace this over. All right, so that's how we get the slants. So let's go ahead and draw a chair, and let's put all the equatorial positions on. It's gonna look like this. It's gonna look like that. It's gonna look like this. It's gonna look like that. It's gonna look like this, and it's gonna look like that. All right, I'll put H's on here. H, H, H. Okay, and these are all the equatorial positions. All right, is everyone comfortable with that? If you got a question, let me, please feel free to speak up. Maybe I can make these a little bolder. Actually. Any questions, please speak up. It's okay. We're already in tutoring time. I hope I'm not a mean person. I don't try to be mean. Sometimes I might say something that I'm not supposed to, but it's not meant to be mean. Okay, are we cool? Everyone's cool? Am I talking to myself again? Hello?
No, sir.
Okay, good. Someone's there. All right, good. So
Mr. Coop,
Yep, go ahead.
can you just go over the cyclic and then that's it?
Sure. And if you need to leave, you can leave. I'm going to try to use the time to answer any questions because I did promise students I'll try to talk to them. But if you have to leave, I've still got the recording going, so you can come back and watch the recording. I'm pretty sure you might have another class or something, so it's okay.
After class, I'm still coming to your office too, Dr.
Okay, please come see me. Okay, so we got the axial positions now, and we also have our equatorial positions, and they have to be outside the ring. All right, so the last thing that we need to be able to do before we can answer questions is that we got to know what top means, or as the same thing as wedge on the ring, and then we also need to know what is the bottom of the ring, or the same thing as a dash, right? And that's how we're going to be able to translate things into the chair conformation. All right, so this is where that knowledge of how a carbon is pointing becomes very important. So let's take a look at this. Let's do our red carbon here. So any carbon that's pointing up, and maybe I should type this out. For carbon points up, the axial position is the same as the top, which means wedge, right? And that means that the equatorial position equals the bottom. Or a dash, okay? Now conversely, if the carbon points down, then the axial position is really saying, which is wedge. The equatorial position now describes the top, which is also a wedge. Oh, I'm sorry. I did something wrong. This is wedge. It should be dash up here. I'm so sorry. Bottom is dash. You dash back. Okay. Any questions there? I know that's, you just got to take the information in. Let's use that appropriately. So on this ring,
Quick question, right quick.
go ahead.
They were telling us, they were saying that this is a 3D. It's not 3D, but it's supposed to represent 3D.
That's
So
right.
when do we know when to use the dashes or not? Because I went to one video and they were saying don't use the dashes and wedges on these. But do you want us to use them?
No. I guess, okay, good question. So I didn't, okay. This is what we're trying to say. In 2 dimensions, you have to use wedge and dash. That's when something's flat like this. But for a chair conformation, you can't use wedge and dashes off of a chair. That doesn't make sense. Or scientifically, that's not how it works. The chair is actually trying to draw things in 3 dimensions. But 2D, we can't put 2 dimensions, so we use wedge and dashes. Does that answer your question?
Yes, sir. I just wanted to clarify that you didn't want us to draw these on our chair conformations. They're
Yes.
just used to explain the acyclic conformation, cyclic conformation.
I guess. I'm not too sure.
It's used to show like what you had up on the top with the 2 wedge, 2 dash.
Yes. You have to be
Like
able.
that represents equatorial. That represents axial, and then the other one is equatorial.
Yes, you have to be able to translate these positions back into the right position on the ring.
Okay.
That's correct. So that's why I'm using the word wedge and dash here, so that we can move between 2 dimensions and 3 dimensions.
Okay, that's all.
Okay. Good. All right, so for this carbon that's pointing up, we only want to do all top positions, all right? Or it's the same thing as saying wedge if I drew it in 2D. So how would I draw the top for that carbon? Can you help me out? Is it the axial position or the equatorial position? What's top for that carbon? Axial position. So I'm going to draw a line straight up. Okay, is everybody comfortable with that? This carbon, we already described it as being pointing down, right? Oh boy, I can't copy that. Give me 1 second. All right, we already described this carbon as being pointing down. So what's the top position here? Is it the axial position or equatorial position? Top for a carbon that's pointing down is equatorial, right? Okay. What's top for this carbon that's pointing up? Axial position. What's top for a carbon that's pointing down?
Equatorial.
Equatorial position, that's right. What's top for a carbon? Sorry, that shouldn't have came that way. What's top for a carbon pointing up again?
Axial.
That's right, axial. And what's top for a carbon that's pointing down?
Equatorial.
Equatorial.
Yeah.
That's right, equatorial. Very, very good. All right, so these are all the top positions, which is the same thing as saying wedge. If I have wedge in any one of these positions, I need to draw my group here. All right, what is the bottom face of this ring? So for a carbon that's pointing up, what's the bottom for that carbon? It's going to be the way. Oh, I didn't teach you guys. It's the opposite. No, it's down right here, carbon. The bottom would have to be the equatorial position, right? Okay. Sorry, it's a misspell there. All right, what about for a carbon that's pointing down now? What is the bottom position for a carbon that's pointing down?
Axial.
That's right, axial. Okay. The slant looks kind of weird. It's kind of slant better. All right, what about a carbon that's pointing up again? What is its bottom position?
Equatorial.
Equatorial, that's right. And for a carbon that's pointing down, what is its bottom position?
Axial.
Axial. Carbon that's pointing up again, its bottom position will be
Equatorial.
equatorial. And the carbon that's pointing down, its bottom position, I'm sorry, will be axial here, right? What did I just do? Okay, so these are all the bottom positions on the ring. These are all the top positions on the ring. All right, you guys want to grow comfortable with this. So let's go back to the original structure. We did this, gotta make this a little bit smaller here. We said we wanted the cis 1,3 dimethyl, right? Can we draw this in the chair as drawn? All right, so I like to always start my numbering in that first upper right-hand corner, and I always number clockwise. So that's 1. All right, this carbon right here will be 2. The carbon next over is going to be what? 3, right? Is everybody comfortable with that so far? Yes, no?
Yes.
Okay. So help me out. I need to put I need to make sure that I'm drawing this chair correctly. 2D structure says that the methyl group should be on a wedge. What is that position on this ring? Is that the equatorial position or the axial position?
Axial.
Okay, good. This should be straight up because it's on a wedge. It's the top. This carbon is pointing up. And for a carbon that's pointing up, the top face is axial. Good. For carbon 3, which is pointing up, I also want to represent this methyl group by being on the top or a wedge. So what position is that? The axial or the equatorial position?
Equatorial.
One more time. Take a look at it.
You said the top or the bottom?
I want to represent the top because I'm gonna.
It's gonna be axial.
Okay, this has to be axial. All right, let me put those letters in here. I didn't put the letters of that. All right, so that's the axial position. I think you guys are comfortable with that. And this is the equatorial position here. All right, is there any questions so far?
How do you know if it's like top or bottom?
By the wedge or the dash?
Okay.
Wedge is the top, and you wedge your head and you dash back. Any other questions? Good question.
Well, Mr. Cooper, when you were looking at the methyl groups, like, how did you know whether you were talking about the top or the bottom?
Oh, because they're wedge, right?
Hmm.
I made them cis. So wedge stands for the top and dash stands for the bottom. Does that help out?
Oh, okay. That's what you're saying.
So both of these are on top face. So the top for carbon 1 was axial, and the top for carbon 3 was also axial. All right, so let's put this in. Let's do the ring flip then. That's just one chair, right? We said there's always how many chairs? 2 chairs, right? All right, they're not gonna let me see all the arrows I'm asking for. All right, we're gonna do the ring flip here. So my chair originally was leaning towards the right, now it's leaning towards the left, right? So I have to move my numbering counterclockwise, right? Hope you guys can realize that this carbon here, let's give it a red dot. When it ring flipped, what in the world? That carbon got pushed down right here, right? So it was up top and I ring flipped it, had to get pushed down. So that means my 1 is not the upper right hand corner anymore. Instead is right here, right? And now my carbon 3 is there and my carbon 2 is in the middle. Is everybody comfortable with that so far? Yes, no? Okay, I'm hoping everyone's with me still. So again, I have to still represent the top because I can't change this molecule. I just changed the chair, but the molecule is the same. And on carbon 1, I have to have a methyl group that's on a wedge. That means the top face. So what is the top face for carbon 1 or the top position? Is it the equatorial position or is it the axial position?
Equatorial.
All right, because it's pointing down, the top for something that's pointing down has to be the equatorial position. Very good. For carbon 3, which is also pointing down, what is its top position? Is it the axial position or the equatorial position?
Equatorial.
Equatorial position again, right? So in this case here, I got 2 cis on the equatorial position, and over here I got 2 cis on a axial position. Which chair is the stable chair, the left or the right?
Right.
Right.
Yeah, this is the more stable chair. That's correct. Can you tell me why?
The
Because all bulky groups are equatorial.
Yeah. I don't know why it starts off with that white fill. Sorry. I used this program for a long time. I realized some things. Okay. All right, this chair is preferred lowest energy. I don't think there's 2 R's in preferred. Okay, any questions there? And you guys told me this is more preferred because large constituents prefer to be equatorial, right? This is a bad molecule here, right? Equilibrium is going to favor this. Can you guys tell me what's bad about this ring? Anyone?
They're both in axial.
And again, Dr. Cooper. Well, it's because they in 1-3 diaxial interaction.
Yeah, that's exactly right. All right, this has a bad thing here. We talked about that being one of the worst interactions you can have. Is this 1-3 diaxial interaction. Ah, that's weird. All right, but these two methyl groups interacting with each other are going to be bad. All right, and 1-3 diaxial interactions are really, really bad for these type of systems. Okay, does that help answer this question for you guys?
Yes.
Okay, good, good. So draw the chair conformation of cis 1,3 dimethyl, either this or that, right? And we realize that this will be the preferred chair. All right, you could have started with this molecule. Your substituents are going to be swapped, right? If you did 2 downs, you first would have drawn this one out, and then you would have re-flipped into this one, but you still would have circled that one, all right? So if you want to, you can do the exercise with the dash version of that, but you'll come to the same conclusion, that the chair with the 2 substituents equatorial will be preferred. All right, I think I did everything, right? Did I miss anything? Any questions? Right, we did nomenclature, acyclic. We did a chair, which is a cyclic. And the other cyclic conformations, you don't have to really know those. You just want to know that they're not preferred. 3-member ring doesn't have any conformations that preferred. The 4-member ring has that puckering that's slightly preferred. The 5-member ring has the envelope that's slightly preferred, and the 6-member ring has chairs. Right? And the chair conformation is preferred for 6-member rings. All right, we identify chiral carbons, and then we also assign a configuration. All right, I'm going to make the quiz available, but it's not going to be due until Monday. All right, so give me a few to go to my office. That quiz, mini review quiz, will be available. I just won't grade it until Monday. I didn't feel comfortable with all the questions. I didn't realize there was questions lingering. So that hopefully gives you guys some time to study. But you want to get that done by Monday, please. It will be posted as soon as I leave this room to go to my office. Okay. Any questions for anyone that's still on the line?
Dr. Cooper, I have a question.
Okay, go ahead. Yes, ma'am.
At the bottom with that chair, when you flipped it, why did you not flip the 2 and the 3? Why? I didn't understand that.
Why did I not flip the 2 and the 3? Let's see.
Like the 1 flip, but does the 2 and the 3 just follow after the 1?
Yeah, the numbering, when you do clockwise, everything just moves clockwise with it.
Okay.
Did I answer your question?
Yes, you did.
Okay, great. All right, is there any other questions?
No, thank you.
Okay, no question.
No, sir.
Okay, good. Quiz will be available shortly, probably within an hour. Due Monday. If I were you guys, I would still take it, right? Hopefully. Okay, I'm gonna put all this in a PowerPoint slide and get it to you guys as well. So if you didn't get a chance to get the notes, they'll be available to you.
Dr. Cooper,
Go ahead. Yes,
when
ma'am.
is the recording going to be available?
When is say that one more time?
The recording, like, when is it going to be available to us?
Oh boy, yeah, that's a good question. It could take a while. It's just a slow download. So when I get these, I gotta download this and then I have to upload it to YouTube, and that process sometimes is long.
So you've been putting it on YouTube now? I thought it was on the streams.
No, I've been sending links. I don't know if you guys been getting my messages in Teams.
Dr. Cooper, the problem with Teams is like if you post something new like I know like the reason why people can't get to the chat is it won't have the join button up there. And then like we have to like for some reason we can't see your lectures when they're posted. Like we have to try to hunt and find them for some reason. They never show up how they used to at the beginning of class, at the beginning of the semester.
Yeah. Oh, yeah. They're not gonna. So the university changed the procedure. At one point, they were going to stream, and then the university cut that service off with Teams. So that means that all I can do now is just get the downloading, and then I have to upload them to YouTube. But I've been trying to send the links. I sent some links yesterday to the videos.
Okay, so I just go underneath the post and then just like search.
Yes, ma'am. You should have those videos linked. I'll do this in YouTube. I'll open the channel. I'll just give you guys the channel so you can just have a channel to watch all those in.
Good. Like at first, I know your channel was private and couldn't everybody see the videos except us.
Yes. I was told not to put. I guess the university was like, you just can't put stuff that's like that. I and I think the reason is that they don't want to. You guys pay for that, right? Well, it's like part of your class, so it wasn't supposed to be not recorded sections. Now, if I make my own recording, I can, but something I do on campus, they wanted it to just be reserved for the students on campus, if that makes any sense. But I can just change that, and I think is okay for the situation. I'm just gonna just make it where you guys can just get access to it. Nobody else knows about it but you guys anyway, so it should be fine. But that was just a university policy. If anything that I do on campus, it should just be reserved for people on campus. But if I make my own video outside of class time, that can be public, if that makes any sense. Okay. Any other questions for anyone? So yeah, when would this one be available? I'll work on it. It probably won't be available until later today if it works. And again, it has to download onto this machine and then I have to upload it to Canvas. And if you guys ever try to download anything, if the internet's not working well, it just doesn't work. And if you try to upload anything, it just sits there for a long time before it's uploaded. But I will try to get it in today. I'm gonna try right now when we close this session. Any other questions? No questions. All right. Please give me about an hour. I need an hour to move from here to get in my office. I'll make the quiz public. All right. You can start the quiz. And if you need more time, I'm giving you that time this weekend. And I'm hoping that that helps. And if you need to see me in office, come by my office, please. Just shoot by and see me. I want to make sure everyone is comfortable with the content. And I do apologize. I want to apologize. I didn't realize. I didn't know. But today I got some feedback and I realized that there were some things that we needed to talk about. Okay, very, very good. If there's no questions or you're gonna come see me in person, come see me ASAP, please. All right, and I'll see you guys on Monday, okay? I will send a Canvas message when the quiz is ready. And you guys are getting my message in Canvas, right? Yes, no?
Yes.
Okay, good. Have a good one. Thank you, guys. All right, so what I'm gonna do now is download the attendance.